Hey guys, Mr. Stead here. We are going to go over heat and matter. This is our second scope. The first one was changes in energy on molecular level, and a lot of the stuff that we're talking about builds off of the stuff we learned last scope. So, if you have not had a chance to view that video, or if you're still confused, you might want to take a peek at that video that's on my channel as well. So, our first thing to discuss is that our overall question, our scope question, is how does heat behave? Our question that we asked the first day, our supporting question, is which has more thermal energy, a pot of boiling water or an iceberg? It's important to note that thermal energy is not the same thing as temperature, which we will talk about here in a sec. So, first, how does thermal energy move? That's another question, another supporting question that we had, and we'll talk about that. Now, energy transfer. Heat and matter is something that we're going to talk about that includes what's called energy transfer. Energy transfer is simply movement of energy from one system to another. So this picture shows radiant energy from the sun helping grass grow, and a grasshopper eating grass, so on and so forth. What's actually happening when you are holding an ice cube is the thermal energy from your hand is being transferred to the colder or cooler ice. So what's not happening is the cold from the ice is not moving to your hand. What's actually happening is the thermal energy is moving into the ice, causing the ice to heat up. So going back to our definition of heat, heat is the transfer of thermal energy from a warmer material to a cooler one. That's what's happening. The thermal energy from your warmer hand is being transferred to the ice cube, which you're touching or holding. So, that's the first part. Thermal energy always moves from warmer to cooler materials. It's never the movement of cold to something warmer. There's no such thing as cold. What we refer to as cold is just something that has less thermal energy. So, now that second part right here, until all have reached the same temperature. Now, that's what's happening. Now, say we have two equal amounts of water. You can see on the screen right here, we have a sample of 50-degree water and 30-degree water. If we mix those two, then we have 40-degree water. Now, that sentence there, until all have reached the same temperature, is important. Now, in this case, when we have equal amounts of water, equal amounts of 50-degree water, and equal amount of 30-degree water, if we mix those, we will meet at the average temperature. However, if we have uneven amounts of water or whatever else we're measuring or using, we are not going to necessarily reach the average temperature. The flow of heat will continue until all have reached the same temperature. Now, if we have equal amounts of water or equal amounts of substance being mixed, yes, we will reach the average temperature if we want to do some math, but just know that, one, thermal energy always moves from warmer to cooler materials, and then two, until all of those materials have reached the same temperature. Another question, how are temperature and thermal energy different? This is a hard concept to separate, but I'll try to explain it as best I can. So, over here on the left, we have thermal energy, and over here on the right, we have temperature. Now you notice that we have the iceberg and the boiling pot of water that we had earlier. So, if we go back to changes in energy on the molecular level, how molecules move in matter, we know that we have kinetic energy within molecules. The molecules are moving. So thermal energy, know that that is the total energy of all the particles in a material, and size of the substance or material matters. On the other hand, temperature. So the way I like to think of temperature is remembering a thermometer. If you think about putting a thermometer in a substance, you hopefully know that it won't change depending on how much of the substance you have. Right here we have 500 milliliters of room temperature water, and here we have a little under 100 milliliters of room temperature water. So I like to compare this by saying which weighs more, a pound of feathers or a pound of bricks? They're the same. So, which has a different temperature? 500 milliliters of room temperature water or 100 milliliters of room temperature water. They're both the same. So, temperature, it doesn't matter how much of the substance you have. If you put a thermometer in it, it's going to read the same. It doesn't matter if we have a room full of room temperature water versus the little cup full of room temperature water. If you put a thermometer in it, it's going to read the same, and therefore they have the same temperature. Now, which has more thermal energy? If you remember, thermal energy is dependent on the temperature, but also the size of the substance. Even though both of these are the same temperature, because thermal energy relies on the size of the substance, this larger sample would have more thermal energy because it's bigger. Although a boiling pot of water has a higher temperature, somewhere around 100 degrees Celsius, which is the boiling point of water, the iceberg is much more massive. So, because the iceberg is colder, but it's so much larger, an iceberg would have more thermal energy.